Hey everyone, welcome to geometry. This is the first video lesson of what we're going to do. So I'm going to go through the video. As we go through the video, there'll be some points where the video is going to pause while you're doing some problems. It's going to ask you to enter in the answers for what you have done before you can move on. That's how I'm checking to make sure that as you're going through the videos, you're able to understand what the process is, what the problems are doing, and you're able to do the solutions. I will put some notes in as I go through to grade them to make sure that everything's going well. You'll kind of see some comments in there as I do it. So let's get started. Our objectives today, obviously, don't worry about those. So simplifying algebraic expressions, that's where we're starting. We're starting with our algebra review. We remember that algebraic expressions are expressions that'll have a variable or something, but doesn't have an equal sign, and we always want to have those in its simplest form. Simplest form means we don't want parentheses, we don't want more than one common term, so we want to combine all our like terms, all this stuff, so it just kind of simplifies down to 3x plus 4. So we're going to use the distributive property if we see parentheses to distribute what's outside the parentheses through everything that's inside the parentheses, and then we're going to combine any like terms. What a like term is a term with the same variable raised to the same power. So we're talking about that if we see two x's. So you have 2x plus 3x. We want to combine those. Those are like terms. The x's are raised to the power of 1. If you see 2x squared plus 3x, then we can't do anything with those. We have to leave those alone because they're not like terms. We really don't know what x squared is because it's just some crazy number. So we can't combine those together. And then obviously we have just numbers kind of hanging out. We want to combine those so it's just one number at the end of the equation. So let's take a look at some examples. First example is we have 4x minus 5 plus 6x plus 10. So like I said, we're going to combine all our like terms. We're going to look through, do we have any like terms? I have x's, so I'm going to circle what I think is like terms. We're going to circle the sign in front of them too, to kind of help us out. So we have 4x and then a 6x, so we're going to combine those. I'm going to switch colors here, and my integers, minus 5 plus 10. So those are the terms we're going to combine. So when I look at it, I get minus 5 plus 10, that's going to become plus 5, because it's really 10 minus 5. When we look at it, we combine our x's, we have 4x plus 6x, so we add the 4 and the 6, that's 10x. So we've simplified that equation down now to 10x plus 5. Second one, we've introduced parentheses now, so we have to remember we need to distribute. So we have to distribute the 2, which is multiply every term inside by the 2. So we do that. I'm going to rewrite this equation here in black just so it kind of stands out a little. We multiply through, I end up with 2 times 6 is 12. Hold on, I want to try to make a concerted effort to do 2's with the loop so it's not confusing. So 12, then xy, we're not going to touch the xy. 2 times negative 8 becomes negative 16. So that's we've distributed everything through. Then I'm just going to bring everything else down. We haven't done anything with everything else yet. So plus 14 plus 7x minus 4y. So now again, we're going to go through and look for our like term. So look, I have 12xy. I have an x and a y, but I don't have terms where it's combined. So this is like one term. The xy is now one term. We have to consider that a term. I don't have another xy, so I'm not going to do anything with that. I have a minus 16 and a plus 14. So I can combine those because they're both integers, they're both numbers, so we combine those. Then I also have a plus 7x and a minus 4y. I don't have any other x term. There's no any other y term, so I can't do anything else with that. So now I'm pretty much just going to add the two numbers together and throw those at the end of our expression because I always want the numbers at the end. So what I'll have is 12 at, whoops, again, we're trying to make it a concerted effort to do loopy 2's. 12xy is my first term. Negative 16 plus positive 14, like I say, it's really 14 minus 16, so that's going to be negative 2. I'm going to throw it at the end. So I'm going to bring down the plus 7x here, minus 4y here, and then, like I said, minus 2. Again, that's our simplified term. There's nothing else we can combine there into like terms, so we're going to leave it like that. Last example, we have 7x squared plus 4x minus 15 plus 3x squared minus 6. We're looking for like terms. I have variables raised to the second power. I can combine those two terms. So 7x squared plus 3x squared becomes 10x squared. Kind of stick it out again. We're going to switch colors here so you see it. I have a plus 4x. I have a minus 6x. Add those together or subtract 6 minus 4, or 6 from 4. I end up with minus 2x. And then the last term, there's nothing I can do with that, so I'm just going to bring down minus 15. So again, that's our final answer. There's nothing else we can do there. The final answer is going to be 10x squared minus 2x minus 15. Sometimes you might have a problem on homework or somewhere that there's nothing you can do because it's already in simplified form, and that's fine. Just rewrite the equation, the expression that you saw in the simplified form. Don't change anything. Okay, so next, this is where the video is going to pause. Here's some problems for you to try. It's 3 examples. Work them through. Then type the answers in the Edpuzzle. And then once you finish that, you'll come back and you'll see your results, see if you got them right. Okay, so here are the answers. Hopefully everybody got these right. I circled the different colors. We're going to combine our x's in the first one, combine our numbers. We end up finally with 2x minus 8. The first example, we distributed 5 through the parentheses. Sorry, in the second example, we distributed the 5 through the parentheses, so I ended up with 5x minus 15 plus 2x plus 27. Then I go and combine my like terms. Again, I circle them by color. I end up finally with 7x plus 12. The last example, combine my like terms. 3x plus 3x minus 6x becomes minus 3x at the end. Negative 54 plus 36 becomes negative 18. So our final answer there is minus 3x minus 18. Hope everybody remembers that. That's kind of the basic building blocks of our algebra to be able to simplify expressions, because we will need to do that once we kind of get into and start solving equations, which is going to be later in this lesson. Okay, so moving on now, we end up with solving our multi-step equations. This is the basic building block, and everything we're going to do in algebra is going to be solving equations. These are the steps we're always going to follow. I talked about having them on a note card. This should be something that you always want to try to remember how to do the steps with as we're solving a problem. And it's always in this order. You may not do every step every time because you may not have parentheses, you may not have fractions, so you may not have to worry about that. But you're always going to start from the top and work our way down. So we're going to use the distributive property to remove any parentheses. Just get them out of the way. Simplifying our expression is what we're trying to do there. Next, we're going to clear any equations or fractions. We'll see how to do that a little bit later. Then you're going to combine any like terms on each side. So we're going to kind of keep the equal sign there as a fence right now, and we're just going to do stuff on each side. Then we're going to move the variables all to one side of the equation. So we're going to do everything we can to get variables just on one side of the equation, all our numbers on the other side. Then you're going to undo the addition and subtraction. That's moving the numbers to the other side. Then you'll do undo multiplication or division, which is just kind of doing the opposite of what you see. You'll see them as we go through the example. So here's our examples already worked out. So we end up with 4b plus 2b, or 4b plus 16 plus 2b equals 46. You see I circled them. I combined our like terms to 6b plus 16 equals 46. The next step was to undo addition or subtraction. I'm adding 16, so to undo that, we do the opposite. We subtract 16 to both sides. Remember, when you're undoing addition, subtraction, and the multiplication and division. You have to do the same thing to both sides. So we subtracted 16 from one side, we're going to subtract 16 from the other side. So we end up with 6b equals 30. We undo our multiplication by division, divide by 6b, you end up with b equals 5. The second example is kind of the same as the first one. I just introduced parentheses. So we ended up with having to distribute 2 through our equation first. So when we distribute the 2 through the parentheses, we end up again with 4b plus 16 plus 2b equals 46. It's the same equation we started with on the first example. So it's all the same steps there all the way through. So we end up again with b equals 5. Our last example, we have minus 36 plus 2w equals negative 8w plus w. So we're going to combine our like terms on this side of our equation first. We're going to combine the minus 8w and the plus w to give us plus 7w. So our new equation is minus 36 plus 2w equals negative 7w. Now we want to get all the w's, all the variables on one side, so you'll subtract 2w from both sides. To do that, we end up with negative 36 equals negative 9w. Now again, we're going to undo our multiplication. We're going to divide both sides by negative 9. We're trying to get the variable by itself. That's our ultimate goal in everything we do in algebra, is get a variable by itself. So we divide by negative 9. We're left with w equals 4. So again, we've solved those 3 problems. Those are the steps. We're going to follow those steps every single time. If you have to think it through, write them down. Just make sure you have them somewhere as you're doing your homework and stuff, so that you know the steps to follow. I'll kind of work them through as we go through some of the problems through our the algebra review. So here's some problems for you to work through. Take a few minutes again, solve them through, enter your answers in the Ed puzzle. They're all just going to be x equals whatever when you're finished, and then come back and check your answers. Okay, so here we go. Here are our answers. I did them out. On your first one, you combine the 5x and the 3x to get 2x, positive 2x. So you end up with 2x plus 4 equals 12. You're going to subtract 4 from both sides to get rid of the 4 on the side with the variable. We want the variable term by itself. So you'll end up with 2x equals 8. Now we're trying to get the variable by itself, so we undo our multiplication by division. We divide by 2. You find out x equals 4. Second example had a distributive property problem in there built in, so we had to distribute 5 through the parentheses. So we ended up with a new equation, 5x minus 15 plus 2x equals 27. We combine again the 5x and the 2x to get 7x. 7x minus 15 equals 27. Undo the addition or subtraction. So to undo subtraction, we do addition. We add 15 to both sides. When we do that, we're left with 7x plus 40, or 7x equals 42, sorry. Here we're going to divide by 7 again to undo the multiplication. You're left with x equals 6. Hope everybody saw that and followed that through, and that's what you were able to get. Last problem was negative 54 plus 3x equals 6x minus 36. So there's some value of x that's going to make that problem true. So we have to get, there's nothing to do. There's no terms to combine on either side. There's no distributive property we need to get rid of. There are no fractions. So we're just going to start with moving variables to one side or the other. Again, some math teachers care that the variable is always on the left. I don't care. I just moved this one over on the left just to kind of keep it consistent with what we did. But what I want you to do is solve the problem the way you're comfortable with solving them, still getting the right answer, obviously. So I moved the 6x from the right to the left, so I subtracted 6x from both sides. That left me with negative 54 minus 3x equals 36. I have to move the 54, undo the subtraction, so I'm adding 54 to both sides. That leaves me with negative 3x equals 90. Undo our multiplication again. We're going to divide both sides by negative 3, which leaves me x equals negative 30. Remember, dividing a positive number by a negative you're left with a negative. Same thing if you're dividing a negative number by a positive number, you're left with a negative. So I hope that made sense to everyone. I hope we kind of figured that out and got those problems done, and this really is just an algebra review as we go through. Okay, word problem. Everybody loves word problems. I want you to try to go through and figure out this word problem, pick out the important parts, try to work it out, see what you get for an answer, and then again, come back and check your work. Okay, so I drew a picture. I always want you to draw a picture when you're kind of working problems where you can, if you can draw the picture. Sometimes you might not be able to, but in this example, we were talking about something that we could draw a picture for. So I drew my building with a side of 70 feet. So when we kind of read through the word problem, you want to make sure you're highlighting important stuff as you go through it. So a carpenter is building a building for a playground. So one side of the playground is the wall of a building that's 70 feet wide. So they told us one side of the playground is going to be a building. They said he also planned to use 340 feet of fencing to build the fence around the playground. That's what he's doing. He's building the fence. So they say what length of playground, what's the length of the playground? So how long is the playground? So how far away is from the building does the playground go if the playground is 70 feet wide? So when I drew my picture out, I knew that the side of the building had to be 70 feet. I knew one part of my fence had to be 70 feet because I'm building a rectangular playground. They told me rectangular. So remember, rectangular playgrounds have the opposite sides are always the same. So I knew if one side of my playground had to be 70 feet over here, then my other side had to be 70 feet as well. So then I had to create my equation. I knew I had 340 feet of fence to use. I had two sides that were going to be the length. So 2L plus 70 was going to equal that 340 to use all the fencing. I subtracted 70 from both sides. I ended up with my two lengths had to be 270 feet total. So I divided by 2. And I find out that the length of the fence, the length of the playground is 135 feet. Hope that made sense. I know it's kind of hard getting a word problem thrown right at you on the first day because I know how much everybody loves word problems. But it was a relatively simple one. Don't worry if you didn't figure it out. I know word problems are hard. We'll kind of work on them, and I'll give you some tips and some strategies as we kind of go through the course. Okay, next, solving proportions. This is a big thing we're going to need to do as we kind of get into geometry. We're going to start comparing shapes and stuff proportionally to see what sides have to be equal. So we're going to need to be able to solve proportions, which was an algebra concept. There are only two steps. Really, you cross multiply and then you solve it as a multi-step equation, which we just went over. So cross multiplying, what I mean by that is you set your equation up as something over something equals something over something like our examples. And then cross multiplying is the top of the left side of the equation multiplied by the bottom of the right side. Then the bottom of the left side of the equation multiplied by the top of the right side of the equation. So in our example here, we end up with 8x equaling negative 28. So when we do that out now, we're solving for x again. So we're just dividing by 8. We've pretty much taken all the other steps away. So we just divide by 8. We're left with x equals negative 28 over 8. So here's one thing I want to talk about. I don't mind if you leave the answer as a fraction, an improper fraction. You don't have to reduce it down to a mixed number. I know people hate fractions, so I'm not going to make you do that. You can leave the equation as something over something. What I am going to insist on, though, is that you simplify it into its lowest term. So if we remember that, awesome. If not, we'll kind of do a quick review of that when you come into class on Monday. So when I look at this, I have to find the least common, or the greatest common factor of 28 and 8, which is 4. So I divide both of those by 4. So I'll end up with negative 7 over 2. So like I say, it's okay to leave your answer as negative 7 over 2. I'm perfectly fine with that. especially in a geometry class where it doesn't really matter, just leave that. To just be used to working with fractions. So I hope that makes sense. Our other example here, we'll do the same thing. We're going to cross multiply 8x times 8. We're also going to cross multiply 2 to x minus 2. Now I'm going to add an extra step in here, which I recommend you doing as well, to remember what we're doing on this. So 8 times x, we just know that's 8x. That's going to equal now 2, and then in parentheses, it's multiplied 2 times x minus 2. So think of it now, we've just created a distributive property. We have to distribute that 2 through both terms, the x and the negative 2. So our next step then is going to be 8x is going to equal 2x minus 4 when we distribute the 2 through. So now just back to our multi-step equation solve problems and process. I want to get the x's on one side, so I'm going to subtract 2x from both sides. I'm already off of the 2's. So I end up with 6x on one side equals negative 4. We're going to divide both sides by 6. So my x is going to equal negative 4, 6, which again I can reduce to negative 2 over 3. So that would be our answer for that example. So I hope that makes sense. We're just cross multiplying top of one side to the bottom of the other on each side, then solving as a regular equation. So again, there's some problems for you to try, work through them, enter your answers in the Edpuzzle, and then come back and check your answers. Again, if you're struggling with it, it's okay. Send me an email saying, hey, Mr. Ford, I really don't quite remember how to do this. Can you go over it again, or is there something else we can do to help me with it? Okay, so when you're finished, you should have these are the answers. We're going to go through, multiply some stuff out. We're cross-multiplying. I color-coded. We ended up with 10y equals 48 for our equation. All we have to do is divide by 10 to get y by itself, so we end up with y equals 48 over 10. Yeah, we can leave it as a fraction. We just have to make sure, is it in the least the smallest terms? It's not, we can divide both of 48 and 10 by 2. So I end up with 24 over 5. Number 11 there, same thing. We multiplied, cross-multiplied. We had to distribute. I didn't do that extra step. If it would have helped you, this would have been 3 times y plus 4, which I would have distributed the 3 through that and got 3y plus 12. So 6y equals 3y plus 12. Want y by itself on one side, so I subtract 3y from both sides. We end up with 3y equals 12. Divide by 3, y equals 4. So again, I hope this is kind of coming back to you, making some sense. Maybe it's something you remember seeing, and now it makes even more sense from before. That's awesome. All right, so moving on. We have two things I want to talk about. I want to talk about problems that have no solution, and then problems that have infinitely many solutions. Because those are the three possible things we can have. We can have no solution. We can have just one number, like we've had, x equaled 4, x equaled negative 2/3. That's a one solution problem. And then we also have the no solutions, or an identity where it works out to be infinitely many solutions. That means any number we plug in for x, or whatever the variable is going to work. Full disclosure, I'm going to try to have every single problem we do is a variable of x. If it doesn't have a variable of x in it, I've borrowed that equation from some other work, and I apologize. So bear with me just for that, but you'll see some that do have different variables. It's no big deal. So our examples here, we have two examples. Trying to figure out, is it a no solution, a one solution, or an identity? The only way you can really do it is you have to solve the problems out. So we're going to distribute our 2. That's our first step in our solution. So I end up with 10 minus 8a equals 10 minus 8a. That should be 10, not an 18 for that first term. Sorry about that. So when I look at this right away, if you look in our notes here for identities, identities are going to end up being Something equals something. So it's going to equal itself. 1 equals 1. 2 equals 2. 2 plus 2 equals 3. That one doesn't work. 2 plus 2 equals 4. So that's what we're looking at when we're talking about an identity. The left side of the equation equals the right side of the equation. So in our example here, I have 10 minus 8a equals 10 minus 8a. If I continue through to solve this problem, what's going to happen is I need to get all the variables on one side, so I'm going to add 8a to both sides. So when I do that, I'm left with 10 plus 8, negative 8 plus 8 is 0. 0 times a just becomes 0, so I'm left with 10 on the left side. Same thing on the right side, I'm left with 10. So 10 always equals 10. So that's our identity. So there are two things you can say. We have infinitely many solutions because no matter what we plug in for a, this equation is going to work. We can plug in negative 3. It'll work. We can plug in the square root of 75. It's going to work. We can plug in pi. It's going to work. It's going to come out so that the left side equals the right side. So when you get a problem like that, what you're going to do on a test or a quiz is just write all real numbers. That's my solution. All real numbers are my solution. Or you can write infinitely many. The more accurate answer is all real numbers. My other example, again, we got to distribute. 6m minus 5 equals 7m plus 7 minus m. Combine my like terms on both sides, I end up with 6m minus 5 equals 6m plus 7. Again, I kind of look at this right away and say, something looks fishy. But still, I'm going to go through and I'm going to move all my variables to one side. I end up with 6m minus 6m. The m's cancel, so I'm left with negative 5 equals 7. And that never happens. So if you want to do that, you just write negative 5, cross out the equal sign, and then your answer on a test or a quiz would be no solution. What that means is there's no number I can plug into this example that's going to make those work. It's just never going to happen. So those are our examples for that. We are going to do a little bit of this on the test when we get to it, or on the quiz actually. So again, next page are some problems for you to try. I have kind of written in here what our answers look like. For no solutions, you're going to end up with, when you get everything solved on, you're going to end up with 1 equals 3. That can't work. That doesn't work. You'll end up with x equals x plus 4. X can't equal x plus 4 because x plus 4 is going to be 4 more than x is. So they don't work. Your identities are always going to be something equals something. 3 equals 3. 2x equals 2x. Pi equals pi. Things like that. So what they mean is the no solution is our equation, whatever we start with, is going to be false. It means it's not going to work for any value we plug in for that variable. The identity is going to be true for any number we plug in for that variable. So again, there are two examples for you. Work through them. Figure out, is there a solution? Is there no solution? Is there an infinite amount of solutions, or all real numbers? And then come back and check your work. Okay, first one, we go through, we kind of look at it quickly and say, wait a minute. They have 5x on each side, so those equal. They're always going to equal. Then I have 9 on one side and a minus 1 on the other side, so those aren't going to equal, so I have no solution on that first one. Second one we look, we combine our like terms on the right, we end up with 9 plus 5x equals 5x plus 9. It's a different order, but it's the same thing because we can do 2 plus 3 equals 3 plus 2 because 2 plus 3 is 5, 3 plus 2 is 5, 5 equals 5. The same thing here, 9 plus 5x is going to be the same as 5x plus 9. So we have an infinite number of solutions there, or all real numbers, whatever you listed. Okay. Fractions. Everybody loves fractions. When you have an equation that has fractions in it, we want to get rid of fractions as quickly as possible. So how we do that is we're going to multiply every single term in the equation, so everything, left side, right side, everything that's in there, by the least common multiple. Think for a minute, try to remember what the least common multiple is. Okay, the least common multiple is a number that when we look at our other numbers, we can multiply to that number. So in our example, when we kind of look at our example here, number 16, my fractions are x over 3, x over 4. I need the least common multiple of 3 and 4. A good problem for fractions will only have two different numbers on the bottom of the fraction. A tough one will be like the one number 17, where now there are two. There are two numbers on the bottom, or three numbers on the bottom of the fraction. So now I got to kind of think of a bigger least common multiple. It's a little harder to find, but it's still possible. And again, I'll show you a trick as well that might make it a little bit easier, but we can get there a different way. So when we're looking at our first example, we'll work through, we can multiply this by 12. Whoops, sorry, wrong 2. I'm going to have everybody yelling at me to make sure I'm doing my 2s right. Okay, so we're going to multiply everything by 12. So when I say everything, we talk about everything. I'm going to write down 12 times x over 3. Multiplied x over 3 by 12. Plus 12 times x over 4 equals 12 times 2/3. So now I've multiplied every term by 12. We're going to kind of cancel some stuff out to make our multiplication easier if we remember. Because remember, we're always thinking this can be rewritten as 12 over 1 for all of these. So we can either just multiply straight across the top, or we cross cancel some stuff. I know 12 and 3 are both divisible by 3, so I can cross out the 3, make that a 1, cross out the 12, and I'm left with 4. So now I'm going to have 4 times x over 1. A little bit simpler math. In here, I can divide 4 and 12 by 4. I'm left with a 1 there. Whoops. This becomes 3. Here, same thing. Again, I'm back to 4. That's a 1. This becomes a 4. So now it's just 4 times 2. Change back to my red. I'm left with 4x multiplying plus 3 times x. Again, if you want, these are all still over 1, but we always remember the ones just kind of cancel each other out and go away. And this is really 8 over 1. So my equation is really 4x plus 3x equals 8. Now we're just back to our multi-step solving process. Combine my like terms. I end up with 7x equals 8. Trying to get x by itself, I divide both sides by 7. I'm left with x equals 8 over 7. Again, I can leave it as 8 over 7. I'm never going to penalize you if you write x equals 1 1/7, but don't do the extra step. It's not worth it because the answer is fine as 8 over 7. If you ever did that and had the fraction there and then you simplified it to a mixed number and you got that mixed number wrong, I'm not going to penalize you for doing that wrong because you had the answer there. I look for the correct answer as I'm doing stuff. Okay, so that was the easier of the two examples. Second one's a little more difficult. We have 3 numbers. We got to come up with a common multiple of 3, 2, and 8. So the trick is, if you don't want to waste any time, the easiest thing to do is just multiply 3 times 2 times 8. You multiply all those together, it's a multiple of all 3 numbers because we multiplied all the numbers together. But there is a better and easier way to do it. What I try to do is I'll pick my biggest number and I'll just in my head think through of all the multiples of that number and see if I can divide the other 2 numbers by that. So 8, I can't divide 8 by 3, so that's not going to work. Sometimes it's as simple as that. The next multiple of 8 is 16. Again, I can't divide 16 by 3 because I want a whole number there, so that's not going to work. My next multiple is 8 times 3. Well, that's going to help me. 8 times 3, that's a multiple of 8 and 3. I can divide that. That's 24. I can divide that by 2. So that means on this one here, I'm going to multiply everything by 24. So now it's just the same process as number 16. I end up with 24. Whoops. You'll see why I want to do the 2's this way, because it could get really confusing. So I have 24 over 1. I'm going to make it over 1 just to kind of help me as well. Times 2x over 3. Plus 24 over 1 times x over 2. Equals 24 over 1. Whoops. Writing too fast. 24 over 1 times 1 over 8. Again, just like I did on the first one, I'm going to color code my next step where I'm going to cross cancel some stuff out. I'm not cross multiplying like a proportion. We're cross canceling to make multiplication easier. I can get rid of that. I know this is 8. So I end up with 8 times 2x. So that's going to be 1. This becomes 12. Whoops. 12. This becomes 1. This becomes 3. Switch to purple to finish this one up. So 8 times 2x is 16x. 12 times x is 12x. Oh my God, these 2's are going to kill me all semester. And that equals 3. Again, combine our like terms, we end up with 28x equals 3. Divide by 28. We end up with x is going to equal 3 over 28. Again, get used to working with fractions. I want to get people comfortable with fractions because they're not really that bad. You just got to get used to them. So those are getting rid of equations with fractions. We got rid of the fractions to solve the equation. You might still end up with fractions in your answer just because we started with fractions in the equation. Does that make sense to everyone? Hope it does. Say, if you're struggling, send me an email. So again, some for you. Figure out what the least common multiple is, multiply everything by that least common multiple, solve the equation, plug your answer into edpuzzle.com, and then come back and check your work. Okay, we should have seen that we multiplied both of them by 6. I was very nice to you here. I gave you fractions of 3 over 3 and over 2 on both of them. So we found the least common multiple. We multiplied everything through. When you multiplied everything on the number 18 by 6, you should have ended up with 4x plus 3x equal to 42. Now we're just back to solving the multi-step equation. Combine my like terms. 7x equals 42. Divide by 7. X equals 6. Once we get rid of the fractions, they become a lot easier. Second one. Again, we multiplied by 6. Go through, cancel everything out when we do our cross canceling. We ended up having to distribute 3 to x over 1. Remember, you might have to put parentheses around something to make it easier to remember to distribute. Common error I always see is 3x plus 1 there. You got to multiply the 1 by the 3 as well. So we end up with 3x plus 3 minus 4x equals 60. Combine our like terms, we end up with negative x plus 3 equals 60. Move the 3 to the other side by undoing our addition. We ended up with negative x equals 57. We can never have a negative x. We always want the variable to be positive. So if you have a negative variable, you need to divide by negative 1 to get rid of the variable. Or you can multiply by negative 1, gets rid of the variable just as well. So I multiplied or divided by negative 1, I end up with x equals negative 57. If you ever wanted to, you can plug those back into the equation to see if they work. Just to check your work. That's what I like about math, is we can always check our work and know what the answer is when we get there. Okay. So here's 4 last problems for you to work through. It's covering everything that we've worked on through today. I want you to plug your answers into Edpuzzle and see how you did. Hopefully you're able to work them all through and get the right answers. Then you can come back and check your work again like always to make sure you got them right. And then that will be the end of your video. Okay, so here are our answers. I'm not going to go through each one individually. Just know you kind of do everything. Distribution on the first one. There was distribution on the second one. There was a proportion on the third one. And there were fractions on the fourth one. Remember, too, when you're looking at proportions, you can kind of solve proportions by multiplying by the least common multiple, but it's easier just to cross multiply. So if you solve number 22 by multiplying everything by 10, that's okay. You should have gotten the same answer. But you don't have to do it that way. It's easy to cross multiply, sorry. So you should have got x equaled 18 over 7, x equaled 7 over 6, x equaled 1, or x equaled 30 over 22. Whoops, that should have been simplified to 15 over 11. My bad there. So I hope that made sense. Put a comment in this last question here for Edpuzzle to let me know how you think, what you're feeling. And I will talk to everyone on Friday.